Hello, guys. Welcome to Ramta Solutions. Welcome to your statistics lesson on the correlation coefficient. So, in the previous video, when we were doing curve fitting, we were talking about how a scatter plot or the data set would be strong positive linear correlation and so on. Right now, we are going to give you a numerical answer to that relationship. Right? So, with our correlation coefficient, one thing you should know, guys, is that it is basically, where's this? Correlation coefficient R is basically between the values -1 and +1, all included. Okay? So, if R is -1 or R is +1, it means we have a perfect correlation. Okay, we have a perfect correlation. That means there is no deviation whatsoever. The data set and the equation that you are getting from your calculator, the least squares, what did we call it the last time? We called it a regression line. The equation that you're getting for the regression line is correct, right? Now, then what if we are getting a correlation that's, perhaps let me say, correlation coefficient that's negative? One that's negative, it would mean you have a negative relationship, right? So what does it mean here? It means here when horizontal values increase, vertical values decrease. No, vertical scale decrease. Now, if you have one that is like this, when R is 0, it means you have no relationship. Okay, it means you have no relationship or simply no correlation. Now, if R is positive, it means you have a positive correlation. Otherwise, you can say a positive relationship. Right? Correlation or relationship, we will be using them interchangeably. Okay. So, now how do you get this R? This R, to get it, it is B, which we can get from your calculator, and I showed you previously its formula, multiplied by standard deviation of the X values over the standard deviation of the Y values. Okay. This is how you can get your R. However, we will use a calculator. Okay. We will use a calculator. Okay. We will use a calculator. So now, here's one thing that you need to know about these guys. Okay. So I'm going to give you the different values and what they would mean. So then we will say, let's see here. So now let's say, maybe let's say this. We did say that when R is 0, maybe let me start here. When R is 0, you get, so when R is 0, there is no correlation. That is to say, no relationship, right? When R is 0, there is no correlation. Now, what happens when R is greater than 0, but less than, let's say, 0.25? You will have a very weak correlation. Now, when this R is greater than 0.25, okay, I've squeezed it, 0.25, but less than 0.5, you will say you have a weak relationship, right? Now, if your R is greater than 0.5, but less than, let's say, 0.75, you can say you have a moderate relationship, okay, or a moderate correlation. Remember, when I say relationship, I can also mean correlation. I'm going to be using them interchangeably. Okay. Perfect. Now, let's now imagine what happens when this R is greater than 0.75 but less than 0.9. This is when we will say it is strong. Okay. Now, when it's greater than 0.9 but less than 1, it's not just strong, it's very strong. Lastly, when this R is equal to 1, it is a perfect correlation. Okay. Now, this is for a positive relationship. Now, what about a negative? Now we can say when R is greater than negative 0.25, when R is greater than negative 0.25 but less than 0. Again, when R is greater than negative 0.5 but less than negative 0.25. Again, when R is greater than negative 0.75 but less than negative 0.5. When is it strong? When R is greater than negative 0.9 but less than negative 0.75. When is it very strong? If it's a negative relationship, when R is greater than minus 1 but less than negative 0.9. And when is it perfect again? When R is negative 1. Remember here, this side here, it's when it's a positive relationship. All right. And this one here is when it's a negative relationship. All right. When it's a negative relationship. So now let's revisit the example we had previously. Okay. We're going to revisit the example we had previously. Okay. In the example we had previously, we had age of an appliance in months, right? And then we had cost in rent. So we said it's 5 months, 10 months, 15 months. Then we had 30 and 20 and 30. Now I have to look for the costs. The costs, okay, I see them here. It's 90, 140, 250, 300, and 380. Right? So now here determine the correlation coefficient, determine the correlation coefficient R. Okay, determine the correlation coefficient R and comment on the relationship. Okay, and comment on the relationship. I recall in the previous video, we found that this relationship gave us y equals 40 plus what? It was giving us 40 plus 12x, but it's fine. I'm gonna show you how we can get this in our calculator. Now here is our calculator. Let me oops. Let me restart. Let me see. let me see. I want to start it afresh. Okay. Let me see something. 3. I'm going to use 2a. Okay, cool. So I'm going to start it afresh, guys. So now what we need to do now is this. We need to ensure that we enter these values here. So the age is the X and then the Y is the Y. So we're going to say mode. We're going to go to statistics, which is option 3. This is if you're using Casio 991. It depends on the region because I'm in South Africa. It's 991 ZA. And then again, you can also, by the way, I want to say, I believe what I'm doing also works for other models, especially if they can have this form that we're looking at. Okay. So let me start afresh. We said it's shift, not shift, man. It's mode. You go to start, it's option 3. Then because it's regression, you're going to go to option 2, A plus BX, right? Then you input the values here. Let's begin with the values of X. We have 5. To enter, we will press equal to. Then 10 equal to, 15 equal to, 20 equal to, 30 equal to. Now to move the cursor to the left or right, you will need to use the up, down, left, up, down, right, left buttons, right? So let's move. I'm gonna go up. I'm gonna insert the values. It was 90 equal to 140, enter. 250, enter. 300, enter. 380, enter. Now we have added everything. We good. Right? We have added everything. We good. Now let me press AC. It is not to clear, to delete everything. It's just to clear the screen. But everything has been stored. Now we go to Shift 1. Let's confirm what we had. So we're going to go to regression. All right. We're going to go to regression. So under regression, I will confirm. By the way, what you're seeing here, what you're seeing here is A plus BX. So let me just confirm them. Okay, let me just confirm them. So as we confirm them, there will be A is option 1. So let's confirm equal to 40. Do you see that? We good. Now, once again, we press AC, or you can just say Shift 1. I'm still going to go to regression file, and then I'm confirming the value of B. You see, the value of B is 12. Perfect. Now I want the value of R. By the way, guys, I remember telling you that R, you can say it is B times standard deviation of the X values over standard deviation of the Y values, right? You can find this, or you can use your calculator. Okay, so now let's see. Once again, Shift 1. Let's go to variance. Oh, do you see this? We have now, let's see. We did find the value of B. It was 12, right? The value of B was 12. Now, what is the standard deviation of the X values? Where is it? Option 3. Where is it? Do you guys see it? It is 8.6023. I'm just going to leave it here. Okay. Now, let's go to the standard deviation of the Y values for, what is it? It's option 6. Do you see that? Option 6. What is this? It is 105,3376. Right? Now we can say, okay, this therefore means the value of our correlation coefficient is 12 multiplied by 8,6023 over 105,3376. Right? So what is this? Now we can say this is 12, open bracket, 8,60 0.23 divided by 105, 3376, right? So let's see what the value of R is. The value of R is 0.98, right? The value of R is 0.98. Guys, this is when you use your formula. However, we are not interested in that. So what I'm doing is when you can perform this in your projects, right? Your assignments. Now, going straight to the calculator, we can find this value. We'll say it is shift R. So the shift 1, we go to regression, which is option 5. Now, what is R? R, here is it, it's option 3. Let's see if we will get this. And here is it, 0.98. Do you see that? You can get it directly, 0.98. Okay, and this is it, guys. This is how you get your correlation coefficient. Okay, this is how you get your correlation coefficient. Now, they said we must comment on the relationship. So the relationship here, we will say, let me do away with this. The relationship here, we will say, this is a very strong, it's a very strong positive linear relationship. All right, it's okay to say this. It's a very strong positive linear relationship. Alternatively, what do you say? You say the age of an appliance and its um and its re and its fixing fee are strongly related, or are directly, I shouldn't say directly related, strongly related. So the more an equipment ages, the higher the cost of fixing. Okay, the more an equipment ages, or the more an equipment is in use, the more an equipment ages, the higher the cost of fixing. This is another way of saying it, but generally you can say a relationship is very strong, positive, and linear. So it's a very strong, positive, linear relationship. Okay, and this is it. This is all that we have done in the first video. Do you now see it, guys? Oh yeah. All right, guys. Re a leboga. We will see you next time when we do past papers. And with that being said, we want to say wish you all the best in your studies. Bye bye.